Welcome to our webinar, Planning Your LoRaWAN Installation. It's the second in a series of webinars that Sensocon is putting on to educate the market on all different facets of LoRaWAN. My name is Heath Jenkins. I'm in product management at Sensocon, and with me is Sabrina Pauly from marketing. She's going to help me keep on track time-wise and curate any questions. Sabrina, you want to say hi?
Hey, good morning.
Thanks. Appreciate your help. And the objective for today's webinar is to detail the planning process, the what, where, when, and how of LoRaWAN installation before you even actually get to the installation point. We want to remove some of the mystery around that process. LoRaWAN, while it's fast growing and becoming very popular, is also somewhat on the fringes and is new to a lot of folks. And anyone that's tried to install a wireless network might be surprised by how easy and simple and straightforward this is. So hopefully this presentation will bring that home. The intended audience is those that are new to LoRaWAN, small to mid-size, maybe looking at a private network, although if someone was looking at a public network, typically in an urban area, there's good things to get from the presentation as well. As always, a reminder that we are recording. We'll make the recording available today, and we will send a link out. So we'll turn that around pretty quickly if you want to go back and look at a spot that maybe you want to give a little more time to. Or you can watch the whole thing again twice in one day. That's okay too. So before we do dive in, I just wanted to talk about why Sensocon, my company, is excited about LoRa. It's akin to the overall internet. I don't want to make too much of this analogy, but I do believe that it's an enabling technology like the internet has been. With the internet, you got e-commerce, you got social media, online education, and just the sheer volume of knowledge that's available and trillions of dollars worth of value created. While LoRa isn't expected to be on that scale, its scalability, cost effectiveness, and flexibility have already enabled a host of different applications like in smart ag, smart cities, industrial IoT, and utility and energy management. So we think it's just on the cusp. We think it's just right there. It's already grown very quickly, and I think the next 10 years are really going to see it bust out into the open. So with that, let's dive in and take a look at the agenda. We're going to do a quick overview of the LoRaWAN wireless network, and it's only quick because it's a simple network. It's made of 4 major components, and if you've seen them once, you've seen them a million times. So for those that haven't seen it, this will be your first time. Planning steps, we'll go through that. That's why we're here. We'll start with the end in mind, one of my favorite sayings from Stephen Covey. Start with the end in mind and define your business objectives, and then talk about the operating environment that you're going to work in that'll help narrow down the devices, the ranges, the number of gateways, those sorts of things that and the type of hardware that you're going to need. We'll do a site review. That started out as a site survey, and after some thought, considered that a site survey just a little too heavy for what we're talking about here. This is it's a pretty straightforward process. You don't need to hire anybody. You don't need thousands of dollars worth of equipment to do it, and signal checks all over your building or your campus. You just need to have a general idea of what obstructions are present and distances that you're working with. Then we'll move on to hardware and software/platform selection. Move into network planning, the placement of those gateways, the sensors, and how to optimize that. And then finally wrap up with the installation plan, sort of an order of operations thing that we'll work through there. Then summary and a Q&A. And if I do this right, we'll finish up at 25 minutes and have a solid 5 minutes for questions. So there's the network map. Many of you may have seen this. You might be familiar with it. And starting at number 1 with sensors, they're just what they sound like. They collect the environmental or industrial data and transmit it long distances to the gateway. They also include some metadata on battery level and signal strength. They get that to the gateway, which receives and processes the LoRa signals. And I say signals because most common off-the-shelf $300-400 gateways can handle thousands of sensors. So these are some pretty impressive pieces of equipment and very affordable to boot. So they convert those LoRa packets, the payloads from the sensors, to IP packets to write on the internet backbone, and they transmit via backhaul network, whether it's Wi-Fi, Ethernet, or cellular, to a network server. And in the process, they also add some metadata like gateway ID, receive signal strength, signal to noise ratio, and a timestamp. So they're also tagging some information. Sending it up to the network server, which you could consider sort of the brain of the network, device registration, authentication, and most importantly, packet routing takes place there to the application server at number 4. That's where the rubber really meets the road. That's what the users are going to interface with, maybe hourly, maybe daily. That's where you can graph and trend, and where the true value of many of these networks really comes into play. So just as a note, we're going to be talking about and focus mainly on private networks. And just know that number 2 and number 3 go away in a public network. They're shared resources at that point for a nominal fee. I say nominal, it feels nominal until you get up to a couple hundred sensors. But folks in urban areas, right now it's built out pretty well in urban areas in the U.S., public networks. You get a little more suburban, a little bit more rural, and not quite built up there yet. So I'm going to focus on private networks today. Now that we've looked at the network, let's take a look at the objectives for the network. So with an emphasis on the objectives and starting with the end in mind, real-time alerts, resource optimization, predictive maintenance, these are all things that could be your objective for the network. Control, compliance reporting, safety, security. And you'll note that I have some things highlighted in red and one thing on this page highlighted in blue. Those are to note subjects or points of interest that are primary filters in the case of red. And what I mean by a primary filter is the answer to these questions may eliminate LoRaWAN. So for example, if you're trying to control something in industrial automation, that's going to filter LoRaWAN out. The response time is just not there. And if you're looking at a primary advantage, something like the regulatory compliance there, LoRaWAN and the system, the way it's set up, is a very nice way to do it. We can store data for months, years, anything, and it can be manipulated and exported very easily. So that's an advantage to an easy to set up network here. So in addition to the regulatory compliance, other data needs might be what data needs to be collected, what parameters, how often does it need to be collected? And that's an important one, and that's a primary filter because LoRaWAN's not going to collect in milliseconds like a lot of sensors out there. It's not going to collect in even seconds. But if you're getting up into the 2-minute plus range and you just need to take measurements at intervals at 2 minutes, 5 minutes, 10 minutes, some setting along those lines, LoRaWAN's a great fit. And then how long does the data need to be retained? We hit on that. Some other considerations. Environment, the geographic scope. This is a primary advantage, again, of LoRaWAN. Building, is it a single building? Is it a campus? Is it multi-site? You can have multi-sites spread out across the globe. And because of the cloud nature of most installations, this is going to be something that you can see from a single computer, all of those sites. Is it citywide, a very wide geography? So that's something to consider as you're planning your installation. Obstructions, always important. We'll talk a lot about obstructions here in a second. And then existing network coverage, that's that public versus private. Environmental conditions, is this going to be outside, inside? Does it need to be resistant to weather? Those sorts of things. And then device considerations. How many sensors are going to be deployed and where? What's the expected battery life? For those that know, I'll apologize in advance for some of the information I'm sharing, but for those that don't, LoRaWAN sensors typically have a 5 to 10 year battery life. So that's usually not an eliminator, but if the difference between a 5-year battery life and a 10-year battery life breaks a tie, for example, then that's a good thing to consider. You actually have stationary or mobile applications in LoRaWAN. Gateway transfer is important. So it's typically within a city that you can go mobile, or maybe in agricultural applications across a field tracking livestock, that sort of thing. So that's something that we'll need to take into account. And then as a single or multi-parameter, a lot of these sensors come with the capability to do to measure multiple parameters. 2, 3, 4. I think I've seen as many as 8 or 9 in a single sensor enclosure, to be honest with you. And then connectivity requirements, range. LoRa is great between 100 feet and 10 miles. And the only reason I cut it off at 100 feet is because below that, you might consider wireless or Bluetooth, but it'll work just fine under 100 feet as well. Data reliability. Do you need confirmed, or is unconfirmed okay? Many applications in LoRaWAN are unconfirmed, meaning there's no acknowledgement and retransmission if you lack an acknowledgement. And that's to save battery because this is a power sensitive technology. So they do come available with confirmed, but many just operate in unconfirmed because the platform will tell you if it misses multiple check-ins from the sensor. So the confirmation won't come, but it'll tell you that it didn't come, if I can put it like that. And the data rate requirements. That's a primary filter because we're talking kilobits, not megabits. So kilobits per second, you're not going to be doing video, you're not going to be doing voice over IP or anything like that. So if you need bandwidth in your application, that's not gonna be a fit for LoRaWAN. And then finally, as part of the operating environment, are you going to do an on-site or cloud-based data storage and processing? The vast majority are cloud-based because you're already dealing with distances and the cloud in general, the internet in general. But it is available on-site. Platform wants or needs. Do you need to be able to export your data? What kind of graphs and trending do you want? All those sorts of things. And some of that's personal preference. And many times you can get free demos on the platform providers' websites as well. And then existing system integration. Are you hooking into a SCADA or an existing ERP? That is possible with LoRaWAN. For simpler applications, you usually can use the application, the platform for webhooks and APIs, but for more complex ones, you might need a separate middleware. And then finally, on this subject, budgets and scalability, the total budget, I put that as a primary advantage because I have been around and seen what some of these networks with other technologies can cost. And I got to say, this is very affordable technology. Both initial cost and ongoing operational costs that are there at the bottom of that. Typically, the only ongoing operational cost is a subscription fee that for small to mid-sized users is going to be sub $5,000, sub $3,000 in many cases. And if you get down into just a dozen sensors, you might be talking $300, $400, $500 per year for all of your sensors. And then scaling, LoRaWAN is extremely good at scaling. The gateways, because they can handle a lot of different traffic from a lot of different sensors, there's no issue with scaling for the most part. So if you can work through that list that we just went through, with special attention on the filtering aspects, you're already a long way towards completing the planning process. We just answered a lot of questions, or we just asked a lot of questions that if you answer, the planning starts to unfold fairly smoothly from here. So now that we have those underlying objectives and constraints defined, let's set up just some important technology or terminology, sorry. And really around signal, because we are going to be talking about signal over the next couple slides. There's two real metrics when it comes to signal that we pay attention to. The first and the primary is signal to noise ratio, SNR. And the second one, secondary consideration, is signal strength. That's RSSI. That is received signal strength indication. And you can see those two, and it's always helpful to know if you have a number lacking any context, that's not really helpful. So this chart right here that I'm using is available all over the internet if you need it. But it basically is going to tell you if you get a signal strength let's say S, a signal to noise ratio number on your platform. And by the way, platforms provide all that information. It's really helpful for setup, that the platform can tell you both your SNR and your SSI. But if you get anywhere between 10 and negative 20 for your signal to noise ratio, you're going to be okay. And since I mentioned it, that negative 20 goes lower than any technology I know, any wireless technology. So you're going below the noise floor, you're going below zero with LoRaWAN and still able to pick up the signal. And Wi-Fi can't do that. LTE cellular can, but just nominally, maybe to negative 4 decibels. So it's really a strength of LoRaWAN in that respect. Secondary consideration. So this is secondary until it's not. And what I mean by that is in some of our testing in a suburban environment, signal strength came to the forefront because we just didn't have a lot of electrical interference. It's more of a commercial area, less of a heavy manufacturing, not a lot of electromagnetic noise in the area. So RSSI was almost always the predominant factor in our, at least in our suburban testing. So you'll see a little bit of that here in a second. So let's look at how obstructions impact. So this looks like a fairly straightforward chart, or a fairly easy to read chart, but there are some elements here that I want to make sure and point out. The x-axis is the distance from the source, from the sensor to the gateway, let's say, in feet. The y-axis is RSSI in decibels per milliwatt. And then wrapping around the top there, we have 3 different obstructions: drywall, a wood door, and 8 inches of concrete. We have bands in the graph in different shades of green, moving from excellent down to moderate and then into weak, to let you know if the signal crosses into those. That's the categorization that we're at. And then we have the 2 lines. That's why we're here, those 2 lines. The top one is free space. We're going to pretend, and just play with me here. We're going to pretend that does not go through those obstructions. So that's just free space. And then the blue line, of course, is going to go through those obstructions. So working left to right, that drywall, and maybe 1.5 dBm. I actually had to zoom in so you could see the drop there. But it does present then a separation between the orange and the blue. So you can see that they separated there because of that obstruction. The wood door, not a lot more, maybe 3 dB drop. So a cumulative 3 or 4 dBm by the time you get to the concrete. And that's where you really see a significant difference. That 8 inches of concrete takes the signal from an excellent to the very lower part of moderate on its way at the end at 1,800 feet to weak. So by the time you get to that 1,800 feet, the difference between free space and that with obstructions is significant. It's 27 dBm, close to 30 dBm at that point. Not an insignificant change. Doesn't mean you have to avoid those. You just have to take it into consideration. One other facet of this that you should take into consideration is that once you're through those obstructions, you got pretty clear sailing, because the bulk of signal loss occurs in the short distances when it comes to any wireless, but LoRaWAN's no exception to that. So as you propagate out from the source, as distance increases, it actually decreases over a wider span. Anyway, the way to say that more clearly, I guess, is, for example, between 1 and 100 feet, you're going to lose 20 dBm. Between 100 and 1,000 feet, you're going to lose that same 20 dBm. So once you're through those obstructions, the point is you're going to just see free space losses, which are much easier to deal with, obviously. So moving on, signal to noise ratio. This is some of that testing we did in a suburban environment. I've got 3 different lines here. The blue is 15 foot with no obstructions. The orange is 75 feet with drywall, a concrete curb, and a vehicle. And then the green is a city block, in essence, a city block, 550 feet with drywall and a building with multiple concrete walls. Now, my eye, I don't know, a lot of times is attracted to the lows and highs. You'll see the low is 4.3 dBm. I think that's an anomaly because most of the time you also see that I have a long antenna and a short antenna. Signal to noise wasn't impacted by that. That ratio stayed consistent, and all three measurements stayed within that same band for signal to noise. And with a lower limit there in red at -20, all three of these are safely, when it comes to signal to noise ratio, within a comfortable band. And the antennas had very little impact. Moving from from signal to noise to receive signal strength. This is that same testing. We just sussed out the RSSI separately from the signal to noise, and you can see the same three distances. You can also see the long and short antenna to the left and right of each of the respective lines. One interesting thing to note is you got the 15 foot at less than -20, or sorry, greater than -20 RSSI. And as you work down 75 feet, you're more like at 40. And then down at the neighbor down the road where we had installed one, you're fluctuating, right under 100 up to even as good as 80. That's with the long antenna. With the short antenna, across the board, we lost 15 dBm. Now, many sensors, this is a differentiator with hardware. Many come with internal antennas. We and several other manufacturers provide an option. Ours comes standard with the short antenna with an option for a long antenna. I think it's like $20. It's not a big spend. And as you can see here, it can really extend your range. So one of the things to emphasize from this slide is it's important to minimize obstructions, know the impact of distance, and consider that long antenna at those greater distances. We've talked a little bit about that survey and signal to noise antennas. Let's look at the hardware and see what sets some of these apart to assist with your selection there. Environment, I mentioned that a little bit earlier. Is this going to be indoor or outdoor? Battery life, again, 5 to 10 years, but maybe that's 10 years is significantly better for you than 5. But realistically, those are a tie for the most part. Probe flexibility. Does the manufacturer have different lengths of probe, types of probe? Can you use other manufacturers' probes? Can you use one that you already have, for example? These are typically low power I2C powered sensors. So occasionally you'll see the 4 to 20, but that's kind of, that goes against the low energy goals that we have for these sensors overall. The frequency band, this is going to be a no-brainer. It's either 915 megahertz in North America or it's not. And if it's not, that's going to be a problem. So just double check and make sure you get that 915 megahertz. Connectivity options, really this is about the gateway. Do you just need Wi-Fi, Ethernet, or can you make do, or do you need or potentially need cellular? Those are the big options out there for gateways, along with the number of sensors that they can accommodate, which typically isn't an issue with small and mid-sized applications. And then how is your hardware going to integrate with the platform? Does it have all the features that your platform can support and that sort of thing? So something to consider. Big takeaway is that amongst hardware, there's minimal feature set difference. The core feature sets are very similar, which makes your job as a buyer and a user a little bit easier. So moving from hardware to software, you're going to select the software platform. If you do a full solution provider, that they provide all the hardware and all the software, that fit's going to be established. That fit's going to be established real well. If you do a third-party platform, you just need to make sure that they're capable of providing a payload decoder. Almost everyone is. I don't know why you wouldn't be, because that allows them to accommodate third-party hardware. So that usually resides on the either the network server or the application server. I think it's more likely to be on the application server overall. So just something you'll need to double check. And then again, you'll want to make sure that the device activation types and remote configurations are all there, and all the features you want are there and available. It's really cool to look at some of these software packages. There's a lot of really neat things out there. And then just picking up the pace a little bit, and out of respect for your time, the order of operations for installation, there's really 4 steps. It is pretty straightforward. I mentioned that earlier. If it's pre-provisioned, in other words, if you're doing a full solution and they've already placed the proper license certificates and keys into the gateway, they've already added devices to the platform, you're going to skip the 3 and 4. It's very close to plug and play. But if you don't, let's pretend you didn't, you're going to need server certificate, gateway certificate, and key file from the platform provider. And then when it comes to the devices, you're going to need the device EUI from the hardware manufacturer, and then coming back again to the platform provider, an app join EUI and an app key. That can seem overwhelming, but these are par for the course. They're readily available from the platform provider and the hardware manufacturer, and it's fairly easy to install them if you need to, if you are buying the hardware and the platform separately. So in summary, planning a LoRaWAN network it's a straightforward process. There are little idiosyncrasies that can pop up from time to time, but there's a lot of good support out there from manufacturers and platform providers. Your big obstacle is something that they run into every day. So there's a lot of assistance out there for that installation process. Knowing and using those sensor gateway placement best practices, avoiding obstacles, and setting distances relative to those obstacles. This is you're not gonna buy a sensor and you get 10 miles out of it. Those are ideal conditions. I love it if you could, but you're probably gonna be looking, more in the single-digit miles, and that would be a good result for many suburban and rural applications. The devices have a limited number of differentiating features. I encourage you to look at a multitude of different hardware suppliers, but I think you're going to find that the core and real difference-making attributes are going to be very similar from device to device. And then plan to use that platform for signal optimization. That's a little-known fact. A lot of people don't know that, but it'll give you your SNR, it'll give you your RSSI. You can move your devices around and check them out and really get them into a place where they're going to work well. So quick webinar. I appreciate everyone attending. And if you took away nothing else, we're going to move into Q&A here in a second. But if you took away nothing else, I'd be very happy if you arrived at the conclusion that a LoRaWAN network is within the reach of your company, and really any company, regardless of size. It doesn't require a deep IT bench. You don't need a bunch of IT support or specialized knowledge, and yet can provide some very valuable, actionable data on a budget. So with that, I'll wrap up, and I will turn it over to Sabrina. And Sabrina, do you have any questions?
Looks like right now I just have 2 questions.
Okay.
To start with, I have early in the presentation, you mentioned public networks. Are those widely available?
So public networks are more widely available in Europe than in the U.S. The cities, for example, typically have a pretty good public network already established. Tampa, which is just maybe a half an hour from where I'm sitting right now, is one of the most covered cities in the U.S., and that extends out into their suburbs. So I think if I drive about 10 miles west of here, I can get to a LoRaWAN public network. I think it's going to happen. I think it takes time. There's some infrastructure there that needs to be built out. But right now, if you're outside of a cone around most cities, and these maps are available online, and if you want, you can shoot me an email, and I'm happy to supply you the names of some of those public networks. But you can check out their maps and see if they're in the area that you're at. What else you got?
Let me see. The other one I have is, I'm in a suburban environment. What can I expect to achieve in terms of range of these devices?
Yeah, that's really the $1,000,000 question. I love that question because I'm going to give you an annoying answer, which is it depends. There's a lot of variables at play, but I hate to leave you with just it depends. So if I had to say, like in an indoor, a fully indoor with walls, maybe equipment, you're probably talking about a half to a mile and a half indoors, just purely indoors. So that is something to consider if you're keeping everything indoors. In a suburban environment, you might get to a mile to 3.5 miles. If you have a low noise environment in the area and no huge mountains or anything like that, you're going to get a pretty good distance even suburban. And that's what our testing has shown around here in Florida. Open fields, if you're in an open field, if you have an agriculture application, or if you're just working in a rural situation, that's where you can achieve more like that 5 to 10 miles. You can get up that far. So obstacles, obstructions, those are the important things, along with knowing about antennas and being able to use those where you want to boost the signal. Was there anything else, Sabrina, that came in while I was talking?
I did have one more question if we have time for it.
Sure.
All right. So how does LoRaWAN support location-based services without requiring GPS modules?
So it does, and that is a hardware differentiator and a software differentiator. Not all platforms or devices support that. So it's something that you can check into, but it does provide that data, and you can do GPS location data. We don't, so I'm going to apologize. I'm not sure of the specifics on those that do, but I have seen it out there. It was one of those where I think we're probably going to add it down the line, but it is definitely something that you can do without a dedicated GPS locator.
Thank you.
All right. Well, thank you everyone for attending. Really appreciate it. We're excited about this technology and really think there's a lot for businesses and not to be too dramatic about it, but for humanity in general, there's a lot to be said about LoRa and what it can provide us. If you have any questions, our information's down there, our phone number or email. You can check out our wireless product at Sensocon.com. And then if you wanted to put a note in it, we're going to focus on some pharmaceutical and clean room applications at the next webinar on Wednesday, January 15th at 11 a.m. So look for those LinkedIn posts and for that to be posted soon. Thanks again, everyone. Take care.